Hey Cooper 6, we're going to do a small group mini lesson with Mr. Grayson and Mrs. Turner. Right? So this small group mini lesson, as it said on your original activity list and on this new one, is about how work equals work and how simple machines help us do that by not actually doing any more or less work than if you didn't have the machine at all. So Grayson has some rope. Mrs. Turner and I have this broomstick. Grayson's going to come stand over right next to me. And the only thing that Mrs. Turner and I need to do is hold this broomstick the way that it is and not let them touch or get closer together. Grayson is going to try to pull with his rope so that the length of his rope starts pulling the two broomsticks together. Right? Do you think that two big, strong adults could stop a 6-year-old? We'll find out. Come stand next to me. Okay? Start right next to me and pull straight on that rope. Hold steady, Mrs. Turner. Keep going. And stop. Okay. Whew, you can let go, buddy. All right. Be right back, guys. Hey, folks, we're back. Mrs. Turner and Grayson went back downstairs and left me alone to do the rest of this mini lesson here with you. So the idea behind simple machines is that the amount of work that you do and the amount of the work that the simple machine does is equal. And you might think that's strange, like what's the point of a simple machine then if it doesn't help you do any more or less work? It's about how that work gets done. Right? So I have our work equations up here. Work equals work. And we know that work is a force times a distance. So now if we take an example of how that work is done without a simple machine, okay, over here, this would be a great example. Right? So we have 50 newtons of force happening over 2 meters. Okay? So 50 times 2 for work is 100 joules. Now, an example of how a simple machine could help you with that is that 25 newtons of force could be done over 4 meters, right? So that still equals 100 joules worth of work, but that distance is much longer and that force is much less. And that is the whole point behind how simple machines help us. And that was best demonstrated by our demo with Grayson and Mrs. Turner. Here are the two broomsticks that Mrs. Turner and I were holding. We had to put a tremendous amount of force over these very short distances between our hands just to hold those broomsticks apart. Right? And we're much bigger than Grayson was. But he came along and he grabbed this long length of rope and pulled it over a much longer distance with much less force. So, much like a simple machine, Grayson was actually able to overcome all of that force that was necessary because he applied it over a much longer distance than Mrs. Turner and I had. So that is exactly how simple machines help us. Work equals work, but it's how you do the work. Thanks, guys.